Hello guys, today we are going to do the daily lead code problem. Find all possible stable binary subarrays 1. In this question, we have given a 3 positive integer 0, 1 and limit. A binary array is called stable if the number of occurrence of 0 is 0 in array is exactly 0 and the number of occurrence of 1 in array is exactly 1. And the third condition is each subarray of array with a size greater than limit must contain both 0 and 1, and the output we have to return the total number of stable binary arrays. Since the answer may be very large, return it to modulo 10 power 9 plus 7. So the question is saying we have given the three positive integers 0, 1 and limit. These are denoting 0 denoting to 0, like number of times the 0 can occur, and 1 is denoting the number of times the 1 can occur in an array, and the limit is 2. So in the example, first 0 is occurring one time and 1 is occurring one time, and limit is 2. So first we have to make the, let us make the all possible array which we can make using this 0 and 1. So the array should be 1 1 1 0 0 1. This is the possible array that we can make. Now let us find the stable array. So the condition for the stable array is if the size of the subarray is greater than limit, then in that subarray no in that subarray, like 0 could not appear continuously, uh, with limit greater than limit times, and also 1 cannot occur continuously greater than limit times. So here if we take the limit is 2, so the subarray we can make greater than the limit is 3. Since there are only two uh, since there is only total two, and the length of the array we can make is 2, so the 3 we cannot make. Okay, uh, let us see it with the bigger example. So in example 3 we have given 0 3 0 equal to 3 times, like 0 can appear 3 times and 1 can appear 3 times in an array, and limit is 2. So in the first subarray we see that the 0 is occurring 2 times, which is less than the limit. Sorry, like if we take the subarray of limit plus 1 greater than limit, then here 0 cannot occur continuously greater than the limit times. uh, for the better clarification, keep let limit equal to 2. I will be talking limit equal to 2 here. So the subarray first we will take is this, and here we see that the uh, no continuous 0 occurring 3 times or greater than 2 times. So in this subarray also no continuous element. So this is our the possible stable subarray. Similarly in this, no subarray contains zeros or ones repeating continuously greater than limit times, greater than 2 times. So these are all the possible subarray which we can make using these conditions. So our output will be 14. So now how can we approach this problem? So it is saying that so the approach is simple. We can use recursion in this. Like uh, initially we will take 0, then we can take 1, then 0, and so let's see this with the first example here. No, 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 this one example. Let us take the third example here. So in third example, we can, if we are taking starting with 0, so the next element we can take is either be 0 or either be 1. And if we take 0, then we have to make sure that the 0 continuously not appear greater than limit time. Okay, so it is still less than. So here, so if we start with 0, so we will check first, is 0 is less than limit. If yes, then we can add 0 also, and one more condition is we can add 1 also. Now here we check that, is 0 less than limit? No, it is not. Then we have to take 1 here. And now again, now again here we can start with taking 0. Okay, as like this we will take, and again check, is the 0 is less than 2, then yes, we can take one more. And now we see that the here 0 occurrence is finished. We can't take 0 greater than 3. So we, and also, so let's code this, how we can code. Okay, so basically the idea will be our recursion. We will take, not take, and each time we will take ones or not take, and zeros we can take or not take if it is less than limit. So here it will be, if we start with 0, start with 0, then we will give here in our solve function 0, 1, and initially mark it as false, and here limit. Okay, and here we will write the solve function int solve, int z, int o, and bool flag, int limit. So when we will the base condition will look like, if we have 0 equal to 0 and 1 equal to 0, both are zeros, then we have one array, and we can add this in our answer. If 0 equal to 0 and o equal to 0, then we will return 1. Now here we will take our answer initially at 0, and if fl equal to false, means here we the 0 is coming. If 0 is coming, then for int k len equal to, one say, len less than, then we can reach length less than limit. Okay, then length can go less than min comma 0 comma limit, and len plus plus. Okay, we can take that much amount of zeros, and here answer equal to answer plus solve, and here 0 will become 0 minus length, this amount of we have zeros left, and o will be as it is, and now we have taken 0. So here we will mark as flag, like we have taken the 0. Here we can mark it as true. Now we can take 1 also. Limit, and here percent mode we will let us not, and then equal to 1a9 plus 7, else we have to count 1, we have to add 1. Okay, so here z will be as it is, 1 minus len, and here we can give false. This will look like this, and at last we will return the answer. And here one, if the array starts with 1, then we will give it as 0, 1, and here true, and limit. This is how, and at last we will return plus percent modulo. Let us run it. It is okay. Somewhere I am making mistake. If it start with 0, base condition is also true. So here we are forgot to writing equal to, as it will be completing all the zeros and ones. I hope it will be running. Now we will memorize the code. We have changing parameters z, o, and this true false. So int memo equal to 201 201, and here 2 times. dp of z o f1 not equal to -1, return this thing. And here do this, we will memorize, initialize it with -1, size of memo. Let's run it. Here we have to write the memo. I think it will run now. F1, this is FL flag. Okay, and one more thing. It is running. Let's submit it.